Okay, well this section here is about multiplying polynomials. So let's just get started with something simple. Say for example I had x times x and I wanted to simplify this down. Well, because they all have a power of 1, of course that doesn't really matter, we have three identical variables here, and we would just add their powers. So this becomes x to the third because there's three x's. But even if I were to have x squared times x to the third, that's supposed to be a 2 there, and we wanted to simplify this, this becomes x to the fifth power. Okay, there'd be 5 x's there. So here's another way of looking at this. X to the fifth times, let's say we had x squared. Alright, this can be rewritten as x raised to the 5 plus 2. So as you can see here, we just add the exponents. And of course this is equal to x to the 7th power. But let's say I had, for example, x squared times x squared. Well, because there's two identical terms right here, we could write x squared, and that's all raised to the 4th power. I don't mean 4th power. Because there's two identical, right, then you would raise it to the 2nd power because there's 2 of them, and that's where that 2 comes from. Now in this particular case, what we do is we multiply the exponents. So this becomes x to the 2 times 2 is equal to x to the 4th. So let's look at that again. If I were to have x to the 3rd times x to the 3rd times x to the 3rd, let's do it one more time, times x to the 3rd, and I wanted to rewrite this. There's 1, 2, 3, 4, so this is x to the 3rd, and it's all raised to the 4th power. And of course, remember, you multiply exponents, so this becomes x to the 12th. Now if you were to look at the other way, where you just add all these, right, 3 plus 3 plus 3 plus 3, which is also going to be x to the 12th. Okay, let's say that I had x times y, and it was all raised to the 2nd power. We can actually break this up and say this is x squared times y squared. So you see, because they both have the same exponent, we could actually group them together and then raise both of them to the 2nd power. So let's look at another one. If I said x times z, use something different, raised to the 8th power, this can be rewritten as x to the 8th times z to the 8th. Okay, let's say for example I had x squared, 3 times x squared times 4 times x to the 3rd, and I wanted to simplify this down. Let's take this 3 and this 4, multiply them together, and then what are we going to do with the exponents? We're going to add them. So that becomes x to the 5th. So as you can see, how we simplified that down. Alright, let's do another one. Let's say I had 5x squared times y times x to the 3rd times y squared. So we want to look at the terms that are alike. Well, we have x squared, we have x to the cube, so we just add their exponents. That becomes x to the 5th. I'm going to carry this 5 over, and then that would become y to the 3rd. Let's see. Let's work with some negatives. What if I had negative 5a to the fourth, let's say, times, use some different letters here, b to the third, times, and I'm going to put in start parentheses here because I got a negative 3 times a squared times b squared. Okay, and we want to simplify this down. So what I'm going to do here is I'm going to take my my coefficients here of negative 3 and negative 5, and I'm going to multiply them together. So negative 5 times negative 3 is 15. And then of course you have a to the fourth. I think I'll just group these first before we go any further. Then we have b to the third times b squared. So now we have 15. Now remember, both of our bases are alike, so we add our exponents, 4, 5, 6, times b, 3, 4, 5. And that has now been simplified down. Okay, so let's multiply this one out. So as you can see, we've got two of these terms, okay, because this is squared. In other words, we have 3x y cubed times 3x y cubed. So instead of writing it this way, we can condense this down and rewrite it like this. Alright, but I don't know, I guess we'll just work this out right here. But if I were to group this stuff, let's see, 3 times 3 is 9, and x, so how about I just write this, since you're learning this maybe for the first time, we'll go nice and slow. How's that? So we have a 1 and a 1, so we add, right? So we have x raised to the 2, and then y, and then we add our exponents to the 6. Easy enough. If we were to look at this, we could say 3 squared, right? Y is to the first power. So this would become 1 times 2 is 2. And of course 3 times 2 is 6. And we get the same thing. So it's more preferred to do it this way. It's a whole lot faster. Okay, I'm going to demonstrate the distributive law. So we're going to take this 3 and multiply it by this x here. So this becomes 3x plus, and then 3 times y is 3y. I mean, what is this really? This is nothing more than saying x plus y plus x plus y plus x plus y. I mean, that's what we're really saying here. I'm going to throw some parentheses around this. And then if we were to condense this down, you could rewrite it because there's 3 of them, you see. But we can go ahead and just do this distributive law here and rewrite it. So let's say that I had 3x times x plus y. Well, we do distributive law, so the distributive property, 3x times x plus 3x times y, and we get 3x squared when we add our exponents, plus, and of course there's not much we can do with that. Okay. Alright, let's look at this one here. We got negative 2xy times negative 3x. So negative 2 times negative 3 is 6. And we'd have x times x is x squared. And then of course we have this y plus negative 2 times this minus 2 is a plus 4. Okay, so we have positive 4, and then xy times y. So there aren't any x's, so we don't have to do anything with that, but we have a y times a y, so that makes that y squared. Alright, so we expanded that one out. Okay, how about we have 5y squared times x squared plus y minus 3y times x minus y. Alright, a little bit longer one here. So I'm going to distribute this 5y squared, multiply it by x squared. So there's really nothing we can do with that other than just rewrite. Plus 5y squared. But because we have a 2 and we're multiplying it by this y here and there's a 1, that's going to become y raised to the third power. Minus 3y times x. And then we have this minus here and we have a minus here, so that's going to make that a plus. And then this is going to be 3y squared, because we have y times y, we get y squared. Okay, can we simplify any of this down? And the answer to that is no, and we're just going to leave it like it is. Well, I think we should learn something new now. Let's say we had, I can't ever remember to close that. Let's say we had x plus y times x minus y. And we want to rewrite this. We want to multiply these two together. Okay, this is how this works if you've never seen it. We have an x times an x, so that's x squared. And then x times minus y. Okay, so you do this first term and then just go through both of these and then go to the next one and then multiply it by both of them. So y times x and let's see, y times negative y, so that's minus y squared. And then of course we want to simplify this down. We have a minus xy and a plus xy, so those are going to cancel out. And we're left with x squared minus y squared. That's the difference of two squares. So we could say that this is equal to x squared minus y squared. Alright, so let's look at another one on that. Let's say we have 3x minus y times 2x plus 3y. Okay, so we take the 3x, multiply it by 2x, so that's going to give us 6x squared, and then 3x times 3y. 3 times 3 is 9, and we just have xy. Minus, because we have a minus here, y times 2x, so that's just going to give us 2yx, and then minus times y minus, let's see, that'd be 3y, so it'd be minus 3y squared, because it's y times y is y squared. And then of course we want to look at this, and is there any way we can reduce this down? Well, we have, let's see, now 6x squared. Let's see, we have an xy and a yx. Okay, so these are like terms here. We have a 9 minus 2, so that would be 7xy minus 3y squared. Good enough. Well, I'm not sure that I actually even mentioned this, but this section is called multiplication of polynomials. Let me write up a polynomial here. Let's say, for example, we have 3x plus 1. And I'm going to write another polynomial. In fact, I will just write it over here. and we'll say that it's just xy. Okay, so these are both polynomials, and this section is multiplication of polynomials. So why don't we multiply these two together? So in other words, I'm going to say xy times 3x plus 1. So xy times 3x is going to be 3x squared y, right, because we have two x's, x times x, plus, and then I distribute the xy across, and that just becomes xy, right? Xy times 1 is xy. Well, that's what we've been doing. We've been multiplying polynomials, but I don't think I actually ever really mentioned it. Let's say that I had something like this written out. Now, this is to the second power. So what this says is that there's two of these. There's an x plus 4 times an x plus 4. So let's go through and multiply these two polynomials together. Let's say this is a polynomial and this one is here, and we're multiplying them together. So remember, take the first term and multiply it by each one of these. So this becomes x squared plus 4x, and then we go to the second one, multiplying them by each one of those terms. So this becomes 4x, and 4 times 4 is 16. And of course we can simplify this down, combining all of our like terms. So 4x and 4x are alike, so that becomes 8x, and then just plus 16. So as you can see, x plus 4 all raised to the second power is equal to x squared plus 8x plus 16. So let's do that again. Let's say we had x minus 2y, and we want to raise it to the second power. So I can rewrite this. In fact, I'll do this down here. This is x minus 2y times x minus 2y. Okay. So x times x is x squared, and then x times negative 2y is negative 2xy. It doesn't matter if I were to write 2yx or 2xy, it's the same thing. And now let's go to the second one. So minus 2y times x minus 2, and I'm going to write it like this, and then minus 2y times minus 2y is a plus because we have a minus and a minus, right? And then that becomes 4y squared because we have y times y. Now we can simplify this down to x squared. We have like terms here, so minus 4xy plus 4y squared. Let's work with a fraction. What if I had x minus a half and the whole thing was squared? So we can rewrite this as x minus a half times x minus a half. So x times x is x squared. X times minus a half would be a half x, and then minus a half x times x, and then a minus a half times minus a half is a positive 1/4, and then we can combine these like terms together. So now what we want to do is we're going to rewrite x squared minus, so a half and a half is just going to be 1. And then plus 1/4. Good enough. I say we work a little bit more complicated one. Next. So what happens when we have x plus 1 to the third power? Well, what this means is we have an x plus 1 times an x plus 1 times an x plus 1. Excuse me. So what I'm going to do is concentrate on these first two here first. Okay? Let's do that. So x times x is x squared. X times 1 is just x. And then we go to the next one. 1 times x is just x. And then 1 times 1 is 1. I'm going to put a parentheses around all of this, and remember we still have this x plus 1 over here. Let's condense this down a little bit, collecting like terms up. We have x squared plus an x and an x, those are like terms, so 2x, and then plus 1. Okay. What I'm going to actually do here is I'm going to rewrite this. I'm going to take this x plus 1 over here to this side. It's not necessary, but I think in explaining this, it might help. Now what we're going to do is we're going to go through the same procedures as we'd go through here, except this time we've got an additional term over here. So we say x times x squared is x cubed. X times 2x is 2x squared. X times 1 is just x. Now we go to the next one. 1 times x squared is just x squared. And 1 times 2x is just going to be 2x, and then 1 times 1 is 1. Now let's see if we can collect up some like terms here. We have x cubed and no other x cubed, so we just rewrite that. We have a 2x squared and an x squared, so those are like terms. So that makes that 3x squared, because 2 plus, and there's just one of these, right? That'd be a total of 3. Plus, we have some more like terms, x and 2x, so that's 3x, and then just the plus 1. So there we go. It's been expanded completely out and written in standard form. So let's look at something similar. I have how many times I gotta forget that, x plus y, and I'm going to multiply that by x squared plus 2x, let's say minus 3. So x times x squared is x cubed. X times 2x is 2x squared, and x times this minus 3 here is going to be minus 3x. Now we go to the next one. Y times x squared, y times 2x, and then y times this minus 3 here, which is minus 3y. Now we want to rewrite this in some kind of, hopefully we can find some like term. Alright, well let's see if we can do something with this. We have an x cubed. I don't know, I'm just going to write it out. We have x cubed plus, let's see, we have a 2x squared and no other like terms. we have a minus 3x, and it doesn't look like we have any like terms there either. We have a y and an x squared, 2xy. Yeah, it's not looking like we can really do anything here. This is a 2xy and minus 3y. Okay, well, that's all we can do there. I just kind of, I guess, rewrote. I didn't even have to do that, but we did it anyway. Alright, well, let's end this with one last problem. Oops, meant to put a parentheses there. Let's multiply this out and call it the end on this section here. Man, so we have 2x times x is 2x squared. And then 2x times y is plus 2xy. And then we're going to go to the next one. Minus y times x is minus yx. Minus y times y is minus y squared. Can we simplify any of this down? Yeah, a little bit. We have 2x squared. These are some like terms here. We have a 2xy minus yx, so that's going to be just a plus xy, and then minus y squared. X squared plus y plus 3. Boy, this ought to do you in here. Okay. So we're going to start with the 2x squared. We're going to multiply the 2x squared times the x squared, so that gives us 2x to the 4th power. And then 2x squared times y, can't do anything with that, so 2x squared y, 2x squared times 3, so that's going to give us 6x squared. Okay, 2x squared times 3 is 6x squared. Then we go to the next one. Plus xy times x squared is x cubed. Y, xy times y is x y squared. And xy times 3 is just going to be plus 3xy. Now we're going to have to go down here. Negative y squared times x squared is negative y squared x squared. Negative y squared times y is negative y cubed. Negative y squared times 3 is negative 3y squared. Now we need to collect any like terms. We don't have, let's see, 2x to the 4th. This may not reduce down, but I'll rewrite it anyway. 2x squared y. Is there an x squared y? Yes, there is right here. And that's the only place. So these are the two here. 2x squared y, x. No, those aren't like terms. What? Okay, those aren't like terms. Plus 2x squared y. Yeah, we don't. Okay, let's see. 6x squared. Okay, I don't see any like terms on that. X cubed y. And there's not anything on that either. Xy squared. No. 3xy. Okay, this thing doesn't look like it can condense down at all. So I'm not even going to bother to rewrite it. Okay, so it reads from left to right. I had to rewrite it on the next line here. But it does not condense down. So there you go.